Have you ever wondered what would happen if a rogue star passed close to our solar system? Picture this: a cosmic wanderer, a star untethered from a galaxy, hurtling through the vast expanse of space. These are what we call rogue stars, and they're not confined to the usual galactic dance. Now imagine one of these rogue stars passing near our solar system. It's a rare event, like finding a four-leaf clover in a field of green, but if it happened, the effects could be monumental. Think of it as a celestial game of billiards with our planets as the balls. The rogue star, with its immense gravitational pull, could nudge our planets out of their well-trodden paths, causing a cosmic reshuffle. It's a fascinating, if daunting, scenario, isn't it? But don't worry, this isn't a doomsday prophecy. It's simply an exploration of the grand scale of our universe and the forces at play. Now let's dive deeper into space and explore what might happen. Imagine a rogue star hurtling through space at an unimaginable speed. Picture a celestial object untethered and free, blazing its own trail throughout the cosmos. This, my friends, is a rogue star. Now, you might be wondering, what exactly is a rogue star? In the simplest terms, it's a star that has been ejected from its original home, its galaxy. It's a bit like a cosmic runaway fleeing from the confines of its previous life to travel the universe alone. Rogue stars are formed in a variety of ways. Sometimes they're the result of a supernova explosion, where the force of the blast is so great that it literally propels the star out of its galaxy. Other times, a close encounter with a black hole can sling a star out of its orbit, sending it hurtling into the cosmic void. These stars are not your average celestial bodies. They're typically massive, often several times larger than our own sun. And they're fast, traveling at speeds that can reach up to 3 million miles per hour. That's faster than anything we've ever created here on Earth. Think of it this way. Imagine you're driving a car at the speed limit on a highway. Now multiply that speed by about 1 million. That's roughly how fast a rogue star can travel. Pretty mind-boggling, right? Rogue stars are also incredibly hard to detect. They're often far away from any source of light, making them nearly invisible to our telescopes. But despite their elusive nature, we know they exist. We've seen evidence of their paths, like cosmic breadcrumbs left behind in their wake. In terms of characteristics, rogue stars are much like any other star. They're composed of the same elements, like hydrogen and helium, and they undergo the same processes, such as nuclear fusion. The only difference is they're not bound by the gravitational pull of a galaxy. They're free to wander the cosmos as they please. So now that we know what a rogue star is, let's see what happens when it gets too close for comfort. Gravity, the invisible force that keeps us grounded, also governs the movements of celestial bodies. Imagine gravity as the silent conductor of a cosmic orchestra, directing the planets in their orbits around the sun. Each celestial body in our solar system, from the smallest asteroid to the largest planet, has a gravitational pull. This pull is determined by its mass, and it's this force that keeps everything in its place, moving in harmony. Now let's introduce a rogue star into this symphony. This star, with its own massive gravitational pull, strays close to our solar system. It's like a dancer barging onto a stage mid-performance, throwing off the choreography. The gravitational balance that our planets have followed for billions of years is suddenly disrupted. What does this mean for our planets? Well, depending on the mass and proximity of the rogue star, the planets could be tugged out of their orbits, sent spinning into new unpredictable paths. This new dance partner would lead the planets astray, disrupting the rhythm they've followed for eons. Planets closer to the rogue star would feel its pull more strongly and could be flung out into the depths of space. Those further away might be less affected, but could still see their orbits altered. And it's not just the planets. Comets, asteroids, even our own moon would be affected by this gravitational disruption. But it's not all chaos and destruction. This cosmic disruption could also lead to new celestial formations, new paths for our planets. It's a reminder that our universe is always changing, always in motion. However, one thing is certain: such a gravitational dance would not be a quiet waltz. It would be a turbulent tango, a cosmic jitterbug with the fate of our solar system hanging in the balance. The effects of such a cosmic disruption would be far-reaching, to say the least. In the aftermath of such a cosmic event, our solar system would be left in disarray. The rogue star's gravitational pull would have tugged at the planets, disrupting their regular orbits. Imagine your favorite spinning top gracefully twirling, suddenly knocked off balance. That's what would happen to our planets. Each planet, depending on its distance from the rogue star, would experience a different degree of disturbance. The inner planets, including our own Earth, could be pulled into more elliptical, elongated orbits. This would mean a drastic change in our seasons, with winters and summers becoming more extreme. Mars might be thrown into a much wider orbit, taking it further away from the Sun and making it a colder and more inhospitable place. The outer planets, giants like Jupiter and Saturn, might actually be thrown out of the solar system entirely. They would become wandering planets, lost in the vast expanse of space. This would leave our solar system looking very different, with fewer planets and a lot more empty space. As for Earth, the changes in our orbit could have serious consequences for life as we know it. The more extreme seasons could make some areas uninhabitable, with scorching summers or freezing winters. Changes in the Earth's climate could disrupt ecosystems, affecting everything from the smallest insects to the largest mammals. But this isn't just about us. A rogue star passing through our solar system would be a cosmic catastrophe on a grand scale. It would change everything we know about our corner of the universe. However, before you start worrying, let me reassure you. The chances of such an event happening are astronomically small. The universe is a vast place, and stars don't often come close enough to each other to cause such havoc. While such an event is highly unlikely, it serves as a reminder of our place in the vast cosmos and the forces at work beyond our control. The universe is filled with wonders and dangers alike, some of which we can barely comprehend. Today, we've journeyed through the cosmos, pondering the hypothetical scenario of a rogue star passing dangerously close to our solar system. We've learned about the gravitational dance, a celestial ballet of sorts where the rogue star and our planets would tango, leading to planets being pulled out of their orbits. The aftermath of such an event would be catastrophic. Our world as we know it would change drastically. From climate shifts to planetary collisions, the consequences are as fascinating as they are terrifying. But remember, this is all hypothetical. The vastness of space and the rarity of such encounters make this scenario highly unlikely. Yet it serves as a reminder of the immense and unpredictable nature of our universe. So next time you look up at the night sky, remember the rogue star and the power of the cosmos that lies beyond our reach.